75% of GeForce gamers play esports. Esports is a game of milliseconds. Reaction time is a combination of the gamer and the machine. Let me explain. This is Valorant. In this example, the opponent is traveling at 1500 pixels per second, and it's visible in this opening for only 180 milliseconds. A typical gamer has a reaction time of 150 milliseconds from photon to action. You can only hit this opponent if your PC adds less than 30 milliseconds. Most gamers have latencies far greater than 30 milliseconds, many up to 100 milliseconds. Today we're announcing a new esports technology called NVIDIA Reflex. NVIDIA Reflex optimizes the rendering pipeline across CPU and GPU to reduce latency by up to 50%. In September, we're releasing Reflex with our game-ready driver. Over 100 million GeForce gamers will instantly become more competitive. Valorant, Fortnite, Apex Legends, Call of Duty Warzone, and Destiny 2 will be the first to integrate Reflex technology. Esports pros and enthusiasts strive for zero latency. For you, we're announcing an insanely fast and beautiful display. A 360Hz G-Sync display designed for esports. This display has a built-in precision latency analyzer. Just connect your mouse. The NVIDIA 360Hz G-Sync esports displays are arriving this fall from Acer, Alienware, ASUS, and MSI. We've made a video comparing gaming on a 60Hz, 144Hz, and 360Hz display. You can see immediately how 360Hz display will help you target and track an opponent. One of the first major AI computer graphics breakthroughs is DLSS. Here's the challenge. Real-time ray tracing is far more beautiful but requires a lot more computation per pixel than rasterization. So the solution is to ray trace fewer pixels and use AI on tensor cores to up-res to super-res to a higher resolution and boost frame rate. DLSS took nearly 2 years of intensive research. We built a supercomputer to train the network. The DLSS model is trained on extremely high quality, 16K, offline rendered images of many kinds of content. Once trained, the model is downloaded into your driver. At runtime, DLSS 2.0 takes in low-resolution, aliased image and motion vector of the current frame and the high-resolution previous frame to generate a high-resolution current frame. I think DLSS is one of our biggest breakthroughs in the last 10 years. Take a look at these images of Death Stranding, the latest game by Kojima-san. DLSS is sharper than native 4K and created detail from AI that native rendering didn't even show, and the frame rate is higher. Adding ray tracing to games dramatically increases the computation workload. Using shaders to do ray traversal and object intersection reduces the frame rate. We added the RT core, which reduces shader workload by 60%. RT core offloads the shaders by doing the ray triangle and ray bounding box intersection calculations. Using the same methodology as Microsoft Xbox, the RT core is effectively a 34 teraflop shader, and Turing has an equivalent of 45 teraflops while ray tracing. Even with RT core, the amount of time consumed is significant. So RT core and shaders have to run concurrently. Even then, 20 milliseconds is only 50 frames per second, and still a step back in performance relative to previous generations. This is where the tensor core and DLSS come in. Rendering to a lower resolution, then using AI and super fast tensor core to effectively double frame rate. Now you can get ray tracing, get high resolution, and high frame rate at the same time. That's the magic of the 3 processors of RTX. NVIDIA's new Ampere GPU, our 2nd generation RTX, 28 billion transistors built on Samsung 8N NVIDIA custom process. All 3 processors double rates over Turing, a triple double. It connects to Micron's new G6X, the fastest memories ever made. The days of just relying on transistor performance scaling is over. Yet Ampere is an incredible 2 times the performance and energy efficiency of Turing. At NVIDIA, we use every engineering lever to squeeze every drop of performance out of the system. And real application performance highlights Ampere's new RT core. The more ray tracing is done, the greater the Ampere speedup. Ampere RT core doubles ray intersection processing. Its ray tracing is processed concurrently with shading. And Ampere can render cinematic images with motion blur 8 times faster than Turing. Let's compare Marble's Turing and Marble's Ampere. You can see dramatic visual quality jump of Ampere. Marbles on Turing runs at 720p 25 frames per second. Marbles on Ampere runs at 1440p 30 frames per second, more than 4 times the performance. And Ampere even did area lights and depth of field. A giant performance leap. Today's games are giant worlds, indoor and out, with photogrammetry, dense geometry, and lots of characters. Games are over 200 gigabytes and getting bigger. This is like 50,000 songs or 400 hours of streaming video. Games have pushed PC I/O and file systems to the breaking point. CPUs copy files from disk and decompress the game image. This is fine when the storage system was slow, 50 to 100 megabytes per second. Now with Gen 4 PCI Express and solid-state drives, PCs can transfer data at 7 gigabytes per second, 100 times faster. CPU copying data to memory and decompressing game images is now the bottleneck. Decompressing data from 100 megabytes per second hard drives takes only a few CPU cores. However, decompressing from 7 gigabytes per second SSDs on PCIe Gen 4 takes over 20 CPU cores. Today, we're announcing NVIDIA RTX I/O with 3 new advances. New I/O APIs for fast loading and streaming directly from SSD to GPU memory. GPU lossless decompression. And collaboration with Microsoft on direct storage for Windows that streamlines the transfer of data from storage to GPU memory. With NVIDIA RTX I/O, vast worlds will load instantly. Picking up where you left off will be instant. This is a very big deal for next generation gaming. Let me show you Ampere in action in one of the most anticipated games of 2020, CD Projekt Red's Cyberpunk. This trailer is called Scenes of Cyberpunk RTX. It shows ray trace reflections, diffuse illumination, shadows, ambient occlusion, and DLSS 2.0. Enjoy. Ladies and gentlemen, our new flagship GPU, the NVIDIA GeForce RTX 3080, powered by Ampere, second generation RTX architecture. The NVIDIA RTX 3080. I have one right here. Let me show it to you. It is beautiful. Look at this. The RTX 3080. It is wonderfully crafted. It's going to look beautiful in your PC, and it lights up. Now let me tell you about some of the other exciting technologies inside. Turing used G6, the fastest memories at that time. The industry thought that was the limit. For Ampere, we had to push through that limit. Working with Micron, we designed the world's first memories with PAM4 signaling, pulse amplitude modulation, with 4 voltage levels that encode 2 bits of data each, 0001, 1011. Each voltage step is only 250 millivolts. So in the same period of time, G6X can transmit twice as much data as G6. PAM4 is extreme signaling technology, and it's just becoming used in high-speed networking. The Ampere thermal architecture is the first ever flow-through design, working harmoniously with PC chassis cooling system, pulling in cool air from the outside, flowing through the GPU, and pushing hot air straight out the chassis. To allow room for a fan to flow air directly through the module, our engineers architect a super dense PCB design that is 50% smaller than previous, while adding the bigger Ampere GPUs, HDMI 2.1, PCI Express 4.0, and G6X. There are 2 independently controlled fans. The bracket front fan pulls cool air from the bottom and pushes the heated air out through the graphics card brackets. A backside pull-through fan passes cool air over the fins of the heat pipe and directs the hot air to the top and back of the chassis to be exhausted by the system fan. The 3080 flow-through system is 3 times quieter and keeps the GPU 20 degrees cooler than the Turing design. It can cool 90 watts more than Turing. The generational leap is ultimately the most important factor of new GPUs. A significant technology advance is needed to inspire content developers to create the next level of content and for the installed base to upgrade. Let's see how the 3080 stacks up to previous generation architectures on the latest graphics-intensive games. 3080 is faster than 2080 Ti. 3080 is twice the performance of 2080 at the same price. Ampere is the biggest generational leap we've ever had. Ladies and gentlemen, NVIDIA GeForce RTX 3080, our new flagship GPU, powered by Ampere, our second generation RTX GPU architecture. Incredible amounts of processing in the shader, RT ray tracing core, and tensor core for processing AI. 10 gigabytes of G6X, twice the processing power of 2080, and at the same price, starting at $699. Available September 17th. One of our most popular GPUs is the 70 series. 970, 1070, 2070 were all hugely popular. You're going to love the new RTX 3070. Faster than the 2080 Ti, the Turing enthusiast GPU priced at $1,200. Ladies and gentlemen, the new GeForce RTX 3070. Let me show it to you. It's a work of art. 20 shader teraflops, 40 RT teraflops, and 163 teraflops tensor core for AI processing. With 8 gigabytes of G6, RTX 3070 is faster than the $1,200 RTX 2080 Ti, starting at $499, available in October. Every generation, we pack in our best ideas to increase performance while introducing new features that enhance image quality. Every couple of generations, the stars align, as it did with Pascal, and we get a giant generational leap. Pascal was known as the perfect 10. Pascal was a huge success and set a very high bar. It took the super family of Turing to meaningfully exceed Pascal on game performances without ray tracing. With ray tracing turned on, Pascal, using programmable shaders to compute ray triangle intersections, fell far behind Turing's RT core. And Turing with ray tracing on reached the same performance as Pascal with ray tracing off. On a technical basis, this was a huge achievement. The images are far more beautiful, and reflection and shadow artifacts are gone. But gamers want it more. They want every generation to be more realistic and higher frame rate at the same time. So we doubled down on everything. Twice the shader, twice the ray tracing, and twice the tensor core, the triple double. Ampere knocks the daylights out of Pascal on ray tracing. And even with ray tracing on, crushes Pascal on frame rate. To all my Pascal gamer friends, it is safe to upgrade now. Amazing ray tracing games are coming. Activision and developer Treyarch are launching a new Call of Duty on November 13th. It's a masterpiece and it looks incredible. There are dynamic lights, ray tracing, shadows and ambient occlusion, DLSS 2.0, and NVIDIA Reflex super low latency technology. The last Call of Duty sold an amazing 30 million copies. Activision put together this trailer of never before seen footage. Enjoy. Let me talk to you about one more thing. Several years ago, we started building the Titan, pushing the GPU to the absolute limit to create the best graphics card of that generation. It was built in limited quantities only through NVIDIA. The distribution was limited. The demand surprised us. Creatives were making 4K movies, rendering cinematics. Researchers built workstations for data science and AI. Bloggers built broadcast workstations. Flight and racing simulation fans built sim rigs. There is clearly a need for a giant GPU that is available all over the world. So we made a giant Ampere. Ladies and gentlemen, the RTX 3090. Come here. Come here to Papa. Alrighty. 3090 is a beast, a ferocious GPU, a BF GPU, 36 shader teraflops, 69 RT teraflops, 285 tensor teraflops, and it comes with a massive 24 gigabytes of G6X. It comes with a silencer, a 3-slot dual axle flow-through design, 10 times quieter, and keeps the GPU 30 degrees cooler than the Titan RTX design. But there's more. The 3090 is so big that for the very first time, we can play games at 60 frames per second in 8K. This is insane. Because it's impossible for us to show you what it looks like on the stream, we invited some friends to check it out. Roll the clip.
Hi. This is Andy and this is Tim. Woo!
I've never been more excited to do anything.
Oh!
Are you kidding me?
Oh my gosh.
Oh my god.
No way.
This is f***ing incredible, dude.
This is amazing.
Holy.
The resolution on this is silly. My God. You can see wear and tear on the treads.
Look at this.
Why is it so detailed? All right. Move fast and shoot things.
This is 8K, sir. I can see everything. Oh, I need to shoot you though.
Not a whole lot of people have seen something like this.
This is so realistic. I feel like I'm really in battle.
This is insane. I want to look at the pretty things. There we go. Dude, the ray tracing is insane on this.
These are the sizzle reels that you see.
This is basically hacks.
And then it's like, it'll never look like that. But it does.
I'm like looking across the vistas, the grand vistas that are happening right now.
Holy shit, look at this.
This feels like a Disneyland experience. Oh, it is so smooth. It's butter.
Oh, it's smooth as shit, dude.
I can't believe it's not butter.
I mean, this is game changing. There's no other way to put it. My mind is blown, dude.
Wow.
Thank you for joining us today, and to all of our fans for celebrating the arrival of Ampere.